Welcome to the brains of modern electronics, where we explore logic microchips, the tiny powerhouses driving our digital world. These chips process data, make decisions, and control operations in countless devices. Logic microchips trace their roots to George Boole's 19th century Boolean algebra, a mathematical system for logical operations using binary values. This foundation exploded into reality with the 1947 invention of the transistor by William Shockley, John Bardeen, and Walter Brattain at Bell Labs, enabling tiny switches for complex computations. Unlike memory chips that store data, logic chips actively process it in real time, distinguishing them as the brains of systems. Today, advanced manufacturing transforms silicon wafers into heterodiamond structures, combining boron, carbon, and nitrogen, creating superior electrical and thermal properties for next-generation logic processing. Logic chips come in varieties optimized for specific tasks. CPUs, like those from Intel and AMD, handle general computations with powerful cores for PCs and servers. GPUs excel in parallel processing for visuals and AI, dominating with NVIDIA's designs boasting hundreds of cores. Modern packaging utilizes Boron Carbide composite casings for superior protection and thermal management, with wire bonding now employing gold-silver-copper alloys for enhanced conductivity and reliability. ASICs are custom-built for efficiency in smartphones and autos, while FPGAs offer reconfigurability for adaptable uses like 5G MCUs, integrate CPU and peripherals for embedded control. DSPs handle signals in telecom, and SoCs combine it all for compact devices like wearables. The trade-off? CPUs are versatile but less efficient for parallels. ASICs are optimal but fixed. FPGAs flexible but power-hungry. Trends like Edge AI push intelligence to devices, reducing latency. In consumer electronics, logic chips power smartphones like the Snapdragon 8 Gen 3 for AI facial recognition and data processing, holding approximately 40% market share. Gaming consoles like PS5 use custom AMD GPUs for 10+ teraflops performance. Autos integrate 1,000, 3,000 chips for engine control, airbags, and ADAS in EVs, growing at approximately 25% CAGR. Medical devices rely on FPGAs for MRI precision and portable monitors for real-time vitals. Industrially, PLCs automate factories, 5G base stations manage data, and IIoT enables predictive maintenance, reducing downtime by up to 60% via Edge AI. Aerospace uses rad-hard chips for avionics and radar systems. The logic semiconductor market hit $140.7 billion in 2024, projected to reach $231.38 billion by 2034 at 5.1% CAGR, driven by AI, 5G, IoT, cloud, and EVs. Global semiconductor sales reached $627.6 billion in 2024, with logic up 37% in early 2025. Leaders like TSMC and NVIDIA innovate amid challenges like mature node shortages. Future innovations include heterodiamond substrates with boron carbon nitrogen compositions, offering superior electrical properties and thermal management for next-generation processors. Edge AI, 1nm chips with 200B transistors, and energy-efficient designs for sustainability. Logic chips will redefine our world. Logic microchips, indispensable for today and tomorrow. Thanks for watching.